Welcome to the video on some basic concepts of chemistry. We will cover fundamental topics including measurement, key chemical laws, atomic and molecular mass concepts, and stoichiometry. This roadmap details the sections we will explore: properties in measurement, uncertainty in measurement, laws of chemical combination, Dalton's atomic theory, atomic and molecular masses, and finally, the mole concept, percent composition, and stoichiometry. Mass and weight are distinct quantities. Mass is the amount of matter in a substance and is constant. It is measured in kilograms or grams. Weight is the force of gravity on an object and varies with location. It is measured in newtons. Volume is the space occupied by a substance with an SI unit of cubic meter. Density is defined as mass per volume, usually measured in kilograms per cubic meter or grams per cc. Higher density means particles are packed more closely. Temperature is measured on three main scales: Celsius, Fahrenheit, and Kelvin. Celsius is used widely in science. Kelvin is the SI unit and starts at absolute zero. The video shows the conversion formulas between these scales. Scientific notation is used to handle very large and very small numbers by expressing any number as n times 10 to the power of n, where n is between 1 and 10. The rules for multiplication, division, addition, and subtraction are shown. Understanding significant figures is crucial for measurement. The video outlines 5 rules for determining which digits are significant. It also defines precision as the closeness of multiple measurements and accuracy as the agreement with a true value. Dimensional analysis, or the unit factor method, is a technique to convert units by multiplying by unit factors equal to 1. The key is to ensure the numerator contains the desired unit and the denominator contains the current unit, allowing for cancellation. 5 fundamental laws govern chemical combinations. These include the laws of conservation of mass, definite proportions, multiple proportions, Gay-Lussac's law of gaseous volumes, and Avogadro's law. Dalton's atomic theory introduced key postulates. Matter consists of atoms. Atoms of the same element are identical. Compounds form from fixed ratios of atoms, and chemical reactions involve the reorganization of atoms. Later discoveries revised some limitations. Atomic mass is relative to carbon-12. Average atomic mass accounts for natural isotope abundances. Molecular mass is the sum of atomic masses in a molecule. Formula mass applies to ionic compounds like sodium chloride. The mole concept connects atomic scale mass to lab scale measurement. 1 mole is equal to Avogadro's number of entities, 6.022 times 10 to the power of 23. Molar mass is the mass of 1 mole in grams, numerically equal to the atomic or molecular mass in U. Percentage composition is calculated by dividing the mass of an element by the molar mass of the compound, multiplied by 100. The video also contrasts empirical formula, the simplest whole number ratio, with molecular formula, the exact number of atoms in a molecule. Stoichiometry deals with quantitative relationships in reactions, based on moles, molecules, volume, and mass. A limiting reagent is the reactant that is fully consumed, thus limiting the amount of product formed. Concentration measures for reactions in solutions include mass percent, mole fraction, molarity, and molality. Molarity depends on the volume of the solution, while molality depends on the mass of the solvent and is not temperature dependent. This video summarized key concepts from basic chemistry: measurement, uncertainty, chemical laws, Dalton's theory, mass and mole concepts, stoichiometry, and solutions. These fundamentals are essential for further study in chemistry.